All right, today we're going to look at analyzing graphs of polynomial functions. On your note sheet, you have this graph of that shows the percent of the U.S. population that was foreign-born with a year since the year 1900. And it says it's given by this equation right here. If you graph this out, that's the graph that we see located over here. Notice that the graph's decreasing from t equals 5, which would be 1905, until the year 1975, and then it begins to increase again. The points at 5 then, which is right here, this point right there, and 75 right there, are called turning points because it changes from here increasing to decreasing, and at this point from decreasing to increasing. We're going to be looking at those types of points today because usually they tell us information about the graph. In this case, they would tell us that the amount of people, the amount of immigrants coming in was decreasing from 2005 to 75, and then after 1975 it starts increasing again. So some terms that you should know, we've heard some of these before, some of them are new. Real zeros, we have talked about this, remember that's where the x value where a function crosses the x-axis, where y equals 0. A new term here, maximum. That is any point where the graph changes from increasing to decreasing. So anywhere where you go from increasing to decreasing, that's a maximum. In other words, no points around it are higher. Maximums are those points that look like that. A minimum is the opposite. It's where your graph changes from decreasing to increasing. Basically, no points are lower. So decreasing is when you have something that looks like that. That point is your minimum. This would be a maximum. So minimums, maximums. Another way or another thing that we call these are turning points. Anywhere where it turns, your graph turns from one to the other is a max or min. So what we're going to look at today is how you can find those and where they're located on graphs and some other stuff. This first one says graph the polynomial function listed here by making a table of values. Describe the end behavior and determine the number of real zeros the graph contains. Okay, so we could graph this out, but we can come up with a table and graph it out over here. You can either plug the actual numbers in. Okay, so for instance, if we wanted to come up with where this is going to be at 0, you could actually plug 0 in here and see what you get. In this case, 0 to the 4th power 0, 0 to the 3rd power 0, 0 squared 0, so that's 0. 4 times 0, 0, so this one's going to end up being 0. And you could plug in those other numbers and do that. Probably the quicker way in this case, though, would be to use some kind of calculating device to come up with our table. So let's do that. So on your calculator or iPad, graph out this, or type in this function here. So we're going to type in x to the 4th power plus x to the 3rd power minus 4x squared minus 4x. And if you hit graph, we should end up with a graph that looks like that. Now, it's kind of hard to sketch that from here over to there. So if we can come up with the ordered pairs of where this graph goes through, it'll be a little bit easier. To do that, you want to go to your table. On this particular calculator, you want to hit your second button and then hit your graph, because right above graph it says table. And it brings up a table. If you have a TI Inspire, hit Control T and it'll bring up your table. If you're working on the iPad graphing calculator, at the bottom menu you should see table. Now, if you look at our table on the calculator, it's going by ones. Our table here, though, goes by halves. We can change that on our calculator by going into the settings. So if you hit second window, right above it says table set, we can have our table, instead of going up by 1, our change go up by 1, we can change it to 0.5. Now it'll go up by halves. So now if we go back to our table, now it's increasing by halves. So we can fill in our table now with these values. So filling it in, this is about roughly 8.4. At -2, it's at 0. At -1.5, it's about -1.3. This next one's 0. At -1/2, it's about 0.9. If we keep going here, we can scroll down a little, get these other ones. 0.5, it's about -2.8. This next one's 6. The next one's about -6.6. And 2 is 0. So let's graph these points now over on our graph. And some of them you got to estimate a little bit, but it'll give us a pretty good idea of what we have here. So at -2.5, it's going to be 8.4, which is a little bit off our graph here. So it'd be 4, 5, somewhere up here. The next one at -2 is 0. -1.5 is -1.3, which is right about there. -1 is 0. Half is 0.9, so not quite to 1. 0 is 0. Half is -2.8, roughly there. 1 is 6, up here somewhere. 1.5 is at negative, or sorry, I wrote this down. It should be -6. So that's right here. The next one's -6.6, right about here. And then at 2, it's 0. So if we connect these, our graph now matches the graph we had on our calculator, or pretty close anyway, if we graph this out. Pretty close to what we had there. All right, so what they're asking us to do is, on this problem, is describe the end behavior. The end behavior is what's happening at the ends of our graphs here. Well, we can see at this left side, it's going to keep increasing. Same with this right side, it's going to keep increasing. So if they both keep increasing, they're both going to keep going up, 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 up. That's going to infinity. So how we write that out is our graph, f of x, is going to infinity as x goes to infinity. That means going to the right. As we go to the right here, as we move this way, our graph's going to infinity. Also, our graph's going to infinity as x goes to -infinity. This one's saying as we go to the left. As our x-axis goes this way, to the left, that's going to -infinity. So that would be our end behavior. All right, next, they want us to say what are the real zeros. Real zeros are anywhere our graph crosses through the x-axis. And it looks like here we have 4 places that it's doing it. There we have a 0, there we have a 0, there we have a 0, and there we have a 0. All those places where we got a y value of 0, that's a 0. So the real zeros would be negative at -2, -1, 0, and 2. And you can see that on the graph. At -2, -1, 0, and 2. Those were the places it crosses through the x-axis. All right, let's try one more. On this next one, they again want us to find the zeros. And this one, though, they're asking us to find some maximum and minimums. So again, let's graph it out first and see kind of what this looks like. So let's put our new equation in. This one is x cubed minus 5x squared plus 3x plus 2. So if we graph that out, this is what the table looks like. So let's kind of make our own little table here and get some points. And if we graph those out here, what we're ending up with for those points, if you graph those out on your table, we got the point -7. That's going to be about -0.9. At 0, it's 2, 2.3. 1, we get 1. 1.5 is -1.4 about. And -2, it's -4, and so on. So I'm just putting those values down here. Now let's actually graph those out and see what the graph looks like. So if we graph those points out, we got a point here. There's a point right about somewhere in there. At 0, it's 2. There's a point there. At 1/2, it's about 2.3, so it's going up a little bit. At 1, it's 1. Got a point about there. At 2, it's -4. There's a point there. Point there. At 3, it's -7. There's a point there. 3.5, we get -5. And at 4, it's 2. So if we connect those, there's approximately what our graphs look like. All right, so they want us to find what are the zeros and what are the maximums and minimum points. Now, you can do this. You can do it by estimating, or we'll show you how you can get it. So first, let's start with the zeros. Where are the zeros on this one? Looks like there's a 0 somewhere over here between 0 and -1. There's another one between 1 and 2. And there's another one over here somewhere between 4 and 5. We've showed you guys kind of how to do those ones, find the zeros. You can use your calculator to do it. If you go to your menu, you can find the one that says 0, and you can locate it by selecting near that point, and it'll tell you where the 0 is. So there's one at about -0.4. And you can keep going and find other ones. We should end up with 3 of them here. If we go to our calculate menu again, select a point to the left and a point to the right. There's another one about 1.2. And we got one more here somewhere over between 4 and 5. So there's another one over here. The other one's at about 4.2. All right, so we got those. Now, how do you find maximums and minimums? Same menu. If you go to that same menu, you should have some other options here. And if you look below 0, there's more options, minimum and maximum. Numbers 3 and 4 on this calculator. They should be on your graphing calculator as well, or the iPad grapher. It should be on there as well. So select whatever one you're wanting to find. Looks like this one is going to have 1 maximum point and 1 minimum point. So we're going to locate those points and see where those are. So you can do that. Select. Let's find the maximum first. So I'm going to select maximum. The maximum looks like it's somewhere over there between 0 and 1. So if you enter 0 as the point to the left and 1 to the point to the right and have it guess, it'll tell you about where it is. Looks like this one's at 0.333333, which tells me it's probably at about 1/3, but the maximum is at about 0.3. Where's the minimum? Do the same thing. This time select minimum instead, and we can find out where that one is. So if we select minimum, the minimum looks like it occurs somewhere pretty close to 3, x equals 3. So if we pick a point to the left and a point to the right, it looks like it is pretty close to 3. It says 2.999999, and I'm guessing that the minimum is at 3. So that would be the maximum and minimum. Now, some graphs may have more than this, but that's what this one has. For tomorrow, I want you to try out number 3. See if you can do problem 3 tomorrow, and we'll check that when you get to class and see how you did on that one.